Hello and good morning, everyone. Great. So you can see me? Are the slides working? Yes. All right. So hi, it's great to be here. I've actually always wanted to visit this museum, so it's great to have an excuse to actually get to be here. I'm going to talk today about the interplay between machine intelligence and the next generation of data products. And I've designed this talk to be somewhat forward-looking, hopefully to give you a few ideas to think over, things that might be provocative, things I'd love to discuss. So feel free to tweet at me, I'm H. Mason, or email if that's easier. It's Hilary at Fast Forward Labs. And we should have a bit of time at the end for questions as well, and I'll be here all afternoon. And I want to start with the statement that when done well, data products really do give us superpowers. And I mean that in the extremely literal sense that they give us the ability to perceive things about the world that are otherwise out of reach of our senses. And they give us the ability to act on those things and to, in some cases, act on the world with a kind of impact that we otherwise could not have. And that's one of the reasons why this is such an exciting area to be working in. But I want to show you something that's my favorite thing on the internet, just to sort of set the stage for where we are in terms of our technical and human social development. And just to say it's the year 2015. This is from Reddit, so I'm sure people here are familiar with it. If not, I consider Reddit to be sort of the armpit of social networks. And I say that as somebody who spent 4 years researching social networks. And I mean that in the way that some really bizarre things pop up on Reddit, and that is okay, right? Also some terrible things, but this is one of my favorites. So this is someone asking the question, if someone from the 1950s suddenly appeared today, what would be the most difficult thing to explain to them about life today? And here's the best answer. So I possess a device in my pocket that is capable of accessing the entirety of information known to man. I use it to look at pictures of cats and get in arguments with strangers. And I have found no better thing on the internet to demonstrate that technology is changing very rapidly, but human nature is staying the same. And in fact, another example of this that was pointed out to me very recently is that we still read and enjoy the Greek tragedies. These are plays that were written thousands of years ago, but they're still just as emotionally compelling to us as they were at the time they're written. And that's because human nature stayed consistent. So here's another one of my favorite photos. This is President Obama on his first campaign trail, and what's remarkable about this photo is that every single person in this crowd has a device. And I still have to use this old photo. I keep looking for new ones, but now the devices are too small to see in a crowd this size. So in this old photo, you can see every single person here has a phone, a camera. In front of him, like by his upraised hand, sort of to the right and down a bit, there's somebody with a laptop who's like, hey, soon to be President Obama. And every single person here is collecting data, but they're not doing this to collect data. They're mediating this social experience through their devices. And that just tells me we live in the future, because that information goes to a place where we can actually start to collect it, analyze it, and use it. Here's another thing I really love. It's from a Tumblr called We Put a Chip in It, which if you haven't seen it, it's totally great. It's basically people taking everyday household objects like toasters, refrigerators, and adding like Wi-Fi to it. It's somewhat satirical of the Internet of Things. But I love this because, well, this particular example is a LED disco suit for your dog. And it lights up in all these patterns. They have a wonderful video where they show the little dog walking around with disco music and disco lights, and everybody's like, oh my God, it's a cute dog in a disco suit. What's amazing about this is that the technology has become so cheap that somebody thought, not just, wouldn't it be cool if my dog had a disco suit? They were actually able to build it, and they were able to market it and sell it as a product. So we live in a world where this technology is so accessible that if you have enthusiasm for any sort of weird dog disco suit-like idea, you can actually build it. And this is wonderful because it allows for all of these sorts of ridiculous but incredibly creative things to pop up. And now I'm not making the argument that we're all going to have doggy disco suits, because I don't think that's the world we're going to find ourselves in. But that when we do have those ideas that are a little bit on the edge, we actually have access to the technology, data, and resources to start to build them today. So I'm going to talk a bit about data science. How many data scientists are in the room this morning? All right, it's maybe half and totally the best kind of audience. If you go, I figured this audience would appreciate just the meta graph of graphs, right? If you look at data science jobs, I don't even have to show you one up and to the right because we've got many up and to the rights, and whoever made the 3D pie chart can get what they deserve, I'm sure. But data science has become a thing. In 5 years ago, it really wasn't. And this is because of these same technical forces that are allowing doggy disco suits to be real. Data science is real, and data science has moved beyond just counting things to actually building data products. I'll show you a few. This is sort of the canonical one. This is, of course, a recommender. And by the way, if you buy one little doggy cute birthday hat for your coworker's dog, you will get these recommendations for all time. So thank you, Amazon, for that. It's not actually a solved problem. We tend to think recommendation algorithms are. Personally, I think there's a ton of work still to be done in that area. But this is a data product. It uses data to give us a capability we otherwise would not have, and it works very well for whatever business is using it. This is a screenshot from Amazon, but every e-commerce site has a recommender because it helps boost sales, it helps people discover things. It's a great data product. Another one I really like is from Foursquare, which is a New York City startup. Where what is impressive to me about this is not so much the product itself, though it's fairly useful, but the way they built an app. They gathered data. So the first app they had was one where you would check into venues, and it was a game. The second version of the app used all the data they collected in that first version of the app to automatically figure out what venue you were in. So it would know from the signal strength on your Wi-Fi, from other Wi-Fi networks around, whatever they were collecting, they would be able to say, okay, you're in this restaurant, not that restaurant. And then they added on this personalization layer later on. And so now the product looks nothing like the product they debuted, I don't know what it was, 5 or 6 years ago, because I can walk into a restaurant and it pops up, I know you love pancakes, you should order the pancakes here, because it knows where I am and it knows what I like. And so that is just an evolution of data products that I found to be very impressive. And few companies seem to be able to really design something to create a data set that is itself a compelling product, use that data set to build features into the product that were just not possible without that data, and then to do it multiple times in multiple iterations. Another one of my absolute favorites is Dark Sky, which takes public US government weather data, gets your GPS location from your phone, and then gives you a micro forecast for where you are standing right now. And I know we're in California, so you're all probably like, whatever, don't care. I live in New York, we care a lot. It tells you you are going to get rained on in 10 minutes. It's very helpful. And another really great example of someone who took a fairly obfuscated and difficult to work with data resource, public data resource in this case, and built a really compelling experience on it. This is one I have not actually tried yet, but I'm super excited about it. So the Google research team is putting a feature into Inbox that will actually help you draft email replies. I've written really crude versions of this myself for years, so I'm very excited to actually give it a try. This is sort of the ultimate email data product, where you don't even have to write the words anymore. It just writes them for you. I'm really excited to see if it's actually good or not. But the blog post was great, so I can recommend that. And the last example I want to share today is, again, probably my all-time favorite data product, and that this is Google Maps Traffic View. And there is something completely remarkable about this. It's a totally trick question. So it's boring, right? This product is incredibly boring. If you've grown up in this society, you have been trained to read these maps since you were little kids, so that part you just get for free. You can sit in your car look at this and make a decision immediately about where you should drive and how you should get to where you need to go with absolutely no understanding of the technology that underlies this product. And when you think about how it works, it's absolutely remarkable. So they're doing all sorts of prediction based on historical data. They're getting real-time data off devices that are actually live running Google Maps out in the world. They're integrating all of this together, and they're visualizing it in a way that is just so obvious and easy to read, even for people who are not tech people, who have no idea how any of this stuff works. And so when we think about what makes a great data product, it's that it can be so boring that it can retreat, the data piece of it can retreat into the background, and people can make decisions in the moment using that product without any understanding of all of the complex, awesome technology behind it. And that's why Google Maps is my current favorite data product, though I'm always looking for more, so if anyone has a favorite, please do tweet it at me. And most of these products could not have been built as they are today, even 5 years ago. And that's really exciting because it means that there's a lot of opportunity for new things that exist now. We work within very different constraints than we did even 5 years ago, which is really not that long. And so when we think about new data products, they have a few different ingredients, and this is completely obvious, but I'm sharing it because it's going to be a bit of an outline for the rest of the talk. So you can't create a new data product without data, obviously. It has to come from somewhere. A technical capability, by which I mean an algorithm. In most cases, we mean machine learning algorithms. In some cases, simpler things still suffice. And people and process that actually know how to go from raw data to some analysis to some product that is actually useful in the real world. And the more work I've done in this field, the more I realize that that people and process is generally a neglected piece of the product equation. And so I'm going to spend the next little bit of this talk talking about that piece and then go back to the technical capabilities because that's where I think, well, that's what I'm personally most excited about. So let's talk about people and how you actually organize people in such a way that they can build new products, because it's not entirely obvious, and the methods that we've used in the past don't necessarily work for data products. We heard that a little bit earlier on the panel that was here just before me, but I'm going to reiterate some of what they said. And first, I want to mention data science, because it's been absolutely remarkable over the last 5-6 years to watch this go from sort of a joke title to a real job title, to have, I get tons of emails, I'm sure you all do, from people who are like, I want to be a data scientist when I grow up, how do I do that? And it's been really fun to watch this become a new thing. And it often gets tied up with a lot of other buzzwords like big data, which is one personally it can go away as quickly as possible because it means nothing. But I think data science actually means something. And this is sort of my favorite way of thinking about what it means. In that data science is a new professional capability where no one piece of it is new at all. So we've had folks doing stats and mathematics for a long time, obviously. We've had people programming and using technology and engineering for a long time. And we've had people communicating, and I'll explain that one a little bit more because it's hard to have one word that means, well, what it basically means is this idea that a great data scientist can sit down with somebody, say, what is the thing you are trying to understand? What are you trying to decide about the world? What do you need to know? Can go away and MacGyver and hack up an analysis with the data and the technical tools they have access to in a reasonable amount of time that teaches them something useful and new, and then can go back to someone else and say, here's what I learned, in a way that that person can actually make a better decision. And so that's the piece of data science that often gets left out of job descriptions. So they'll give you a list of technical capabilities, and maybe you need 10 years of experience with R or whatever nonsense, but they won't really talk about how those things interact in your professional capacity. And so a data scientist today is doing these three things. So they're doing math and stats and modeling and prediction and all that fun stuff. They are programming at least competently enough to write SQL queries, and often they are engineers as well, though not always. And then they are able to communicate what they learn either through just telling someone about it in a way that's robust and useful, or in some cases building a product. And so this is why I think data science actually deserves its own job title. It does deserve to be made distinct from either engineering or from statistics or analytics, though that job title has become somewhat indistinct as well, because you have all these capabilities together. But that's just data scientists. That is not, we haven't seen the same kind of change in leadership and management, but it's absolutely necessary. So you can't just say, I'm going to bring in all these people with a new job title and a new set of skills and new capabilities that they bring to our product and engineering and analytics and business organization, but I'm not going to change my management philosophy or culture around business or any of that. That just sounds like nonsense, and it is, and yet practically that seems to be what happens quite often. And so lately I've been making the argument not to data scientists who know what they're doing and are great at it, but around the friction that comes when you introduce a new job into a company where the setup has not been designed to accommodate that job or that capability, and you end up often with people getting underutilized or overburdened. There are a couple of failure modes, and they're equally poor. Because we really need to adapt the way we manage data science and data products to take this into account. And some of that process stuff I wrote up in this short book that I co-wrote with DJ Patil, who now works at the White House. And I think there are some of them here because I saw a book signing on the schedule. Calling it a book is an exaggeration. It's 22 pages, so it's more like a blog post that someone printed out and bound up. But it's free, and it has all of this stuff written down. So if you need a prop that you want to wave at your manager, please go grab one. But I want to just talk briefly through some of the ways of thinking about data projects that have been really useful for me. And then I will get back to the cool technology stuff. A lot of people say, okay, so I got a job in this organization, and now I'm supposed to just do data science, but nobody's really telling me what to do, so how do we get started? And the first thing to do is to really say, what data do we have? And this is a very simple question with a ton of nuance, right? Because what data do we have? Where did it come from? How is it collected? What's the provenance? What are the governance requirements around it, which, if you're in certain industries, are very important to understand? And where is it controlled? If you're in a large company, you'll find it lives all over the place in different silos, and different political issues arise, getting access to it. And even startups generally don't know all the data they have, so just writing it down is a very useful exercise. Sort of saying what data should we have based on all of the things we understand about the product and business, or even what servers are we paying for and what should be there, and how do we get that in. And again, even in small companies, there's always a ton of work to do to make sure the right things are being collected correctly. And then what assumptions do I make that I can now experimentally verify using this data? So what do we believe about our product, our customers, all that stuff that we can now actually validate? And you will find that you'll learn something cool when you do that. And then you can start to ask questions. And this came up earlier on the panel, which is that the capital A agile development process is a really poor one for research. And this is a tension that I've seen at companies I've worked at and a lot of the companies I work with, either as an advisor or as clients, where they sort of think, okay, this is mostly like software development because data scientists are writing code, so we're just going to sort of shove them into that process and it's going to work. And of course, it doesn't work. And so I try to promote a few simple questions you can add on top of that process to sort of make it easy for everyone to understand what's going on. And the first one is really simple. So what is the problem we're actually trying to solve? And this is the kind of thing that technical people think is trivial to answer, but it's actually quite difficult to answer this question in plain language that anyone can pick up and understand. Not just you and your closest colleague, but if your CEO picked it up, they should have some idea what you're talking about. And this is really, the research problem statement. And the second thing is, how do we know when we've won? Or what is a successful error metric for an answer to this question? And in machine learning, we often have a quantifiable error metric, which is fantastic. But we also often don't. And one thing I found is that admitting when you don't is really important. So when I worked at the social media analytics company called Bitly, we built a real-time search engine. And we understand how companies like Google and how Microsoft with Bing do their search engine algorithm quality evaluations, and we could not afford to do the same thing. And we also just did not have an easy quantifiable metric for error between two algorithms. So when we answered this question, we had to write down, we don't have a robust metric. We're going to try it out in the office with a couple of blind tests, and we're going to see. And that's going to be good enough for us. And so being able to write down not just what it is you're trying to research, but when you will know when you have a successful answer is really important. And then the third thing, especially if you're at a company where you're trying to move quickly, assuming we've solved this question perfectly, what's the first thing we'll do with it? And there's a bit of subtlety to this, because you want to make sure you're working on something relevant. So I've had folks get very excited about questions that were not always directly relevant to product, or to opening up new product opportunities, or to the business. And you want to make sure there's a way to sort of rein them back in as a manager and say, OK, that's really cool, but is it useful? And the second thing is this word first, which is here, because I believe that as somebody building a data science capability inside a company, it is your job not just to do little independent, naive projects, but to build things that build on top of each other. And my metaphor for this has always been the civilization tech tree. So if there are any old school gamers in the room, you'll know if you get the wheel and you get the horse, you can build the chariot. And this to me is the perfect metaphor for doing research on data inside a company, because you can always look ahead and say, if this works and that works, we have the capability to address this question that we could not address before. And so especially if you're managing a team or managing yourself, being able to say, I'm going to pick this thing to work on, not that thing, because if this works, I get 3 more things I can do, and if that works, it's a standalone, is a really helpful way to think about prioritization, which is really the hardest part. And then next, if we actually do this thing, does it have a big impact, or is it an incremental improvement to something no one will care about? And that's pretty obvious. And finally, my favorite but completely optional question, so you'll see it has no number on it, is what is the most evil thing that can be done with this? And I ask this for 2 reasons. One is that most data scientists I've worked with are very lawful, good people. They went to school, they did really well, they probably have a PhD, they followed all the rules, they got a good job. And that means that sometimes the creativity, your creativity gets a little bit constrained by following rules. And so when you put people in a position where you say, you are sitting on top of a volcano lair with your little disco puppy, and you are trying to imagine the most horrible thing you can do with this capability or this bit of data, you get really wild and excellent ideas. And they're mostly terrible, but that's great, because good ideas can come out of terrible ideas. And so it is also a lot of fun to sort of invert the way you think about the work you're doing. And the second reason I think we need to ask this question is because the ethics of the systems we build is one of the biggest questions in the field today. DJ, my co-author, was tweeting yesterday about how all data science curriculums should have a data ethics component in the curriculum. And being able to imagine what could go wrong before a product actually gets out in the world is really important. And it won't ever fix all potential problems, but it will definitely help you think through the design of the system you're building. And so a bunch of goals. When you manage data science and data research projects, really to communicate effectively, manage the time so you don't go down year-long rabbit holes and come back with nothing, develop wisdom over time from working with the data, which is something I think we don't talk about enough, is that when you work with a data set for a long time, you start to learn intuition about what it can tell you about the world, which may sound like the most unintuitive thing because we're talking about data, but it's true. And then look for those wild ideas and those opportunities for experimentation. And this is possible anywhere, whether you're at a startup or a big evil company. Totally possible. All right. So that was my process and people and culture part of the talk. I'm going to spend the rest of the talk talking about emerging capabilities in machine intelligence and some of the new kinds of products we're starting to see come out of those. And also, thank you for bearing with me. I'm just getting over the flu, so if you haven't gotten your flu shot yet, please get it. It's a really bad one this year. Yeah. So AI has come back in a big way, right? It's a term that we abandoned in the 90s and early 2000s. And now it's back, and it's probably a great existential threat to humanity, if you believe that. I don't, personally. But I do really love this idea that AI is whatever a computer can't do today. So in 1997, Garry Kasparov beat Deep Blue, and AI could suddenly play chess. So before that, AI could not play chess. Chess was something that was purely in the realm of human creativity and intellect. And these days, we have Google self-driving cars, and I keep hearing people bitching about them in traffic and how they don't know how to do U-turns. But this is a remarkable achievement. A car can drive itself. Like, that's AI, right? Except, AI couldn't drive cars until suddenly it could. And so we're starting to see AI or machine intelligence sort of move from things that are purely rules-based and repetitive into things that we would have considered much more creative and requiring dynamic creative problem solving today. And that opens up a ton of possibilities. So this is from Siobhan Zillis, who's a venture capitalist at Bloomberg Beta, where I think it's really useful to look at this. So she's looking at machine intelligence startups and products that are out in different little bits of the industry today. And it's really useful to look at this sort of map. And if you Google it and Google her name, you'll find it. Because these things always start in very defined high-value domains. Generally, you'll find them in finance, pharmaceuticals, in some cases manufacturing or agriculture, places where people are willing to invest a huge amount of money in automation, and then they get applied to less financially lucrative domains, and they become much more generalized. So this is a useful place to look for what's happening today. And this is what we do at my company, Fast Forward Labs. So we sort of live in the middle of a bunch of different communities where we work with startups who are really interested in data and machine intelligence products. Most of our clients are actually large companies that have data and are interested in building products but aren't familiar with the technical capabilities. And then we also are all sort of reformed academics, like folks who love research but also like to build things. And so that's the world we live in. And there's a lot of need for folks like us. So we're basically an independent machine intelligence research group. There are 9 people on the team from a whole mix of backgrounds. You could call us data scientists. You could call us engineers. Whatever feels most appropriate is fine. But there's a huge interest in this, and I don't think it's going to go away because the pace of technical change is increasing, and the expertise is really hard to come by. And so we spend a lot of time thinking about how we find these machine intelligence capabilities and what's going to be impactful. And so I'm going to share our methodology and then specific capabilities that I think are really exciting, and then that's going to be it. And so we've come up with a bit of a robust process around this, which is a little bit loose and chaotic, which is sort of how I like it. The first step, really, is to have a ton of coffee, get everybody hyped up on sugar, and come up with as many bad ideas as possible. And that means, talking about science fiction, reading articles, looking at what's coming out in the market, going to conferences and seeing what other people are excited about, all of that stuff. And then you get a pretty long list of things that range from, let's do regression analysis, to, cryogenics, things that are entirely practical to entirely impractical. And then we go through and evaluate each one with an eye towards why is this more possible this year than it was last year. And there are really 4 reasons why that happens. So the first reason why is that there was a theoretical breakthrough that gives us a capability that just did not exist in the world before that allows us to address a problem. And these things happen really rarely. Occasionally, they happen where somebody is using a technique in one domain that if you look at it, you can understand that it would be useful in another domain where it has not been applied. So it's not the kind of eureka breakthrough we like to think of, but the kind of breakthrough where progress in one domain just hasn't made it over the barrier into another application. But a theoretical breakthrough is possible. A change in the underlying economics of the things that constrain the application of that technique. So, I could make or find a graph, yeah, that one came from here, of CPU cost, GPU cost, memory cost, hard drive storage cost, anything, and it looks like this. And then I've seen this one on Twitter. This is on the left, the 2005 SD card, which is 128 megabytes, and on the right, the 2014 SD card, which is 128 gigabytes. So same cost, orders of magnitude in change in value. And so there are a few things you might want to do that are currently too expensive, but if you watch, you will see when it might become possible to use those techniques pretty broadly. The third thing we look for is commoditization. So something maybe might be understood theoretically, but there is not robust open source code that people can build on top of yet. The classic example of commoditization in data science is Hadoop itself. Whereas, the Google paper came out talking about MapReduce, it was sort of it was well understood how to do that. But at the time, you would have had to hire a team of like 20 engineers to build your own distributed processing framework. Once Hadoop existed, you had to hire maybe 2 engineers to, install, configure, maintain, and run it. And now you can go spin up a cluster in the cloud in one line where you don't even have to know where in the world the machines are. It has become a commodity that the rest of us can build on top of, which makes it much more accessible. So again, it's not making something possible that wasn't possible before, but making it accessible. And sometimes this goes wrong. So there was a company called Face.com that had really world-class face recognition in 2007. And again, this is the kind of thing you might laugh at today because it's very easy to do face recognition today compared to then. This company was bought by Facebook and it was shut down. And so a bunch of people had built on top of it. They were a very developer-friendly company. And then if you go to their site today, it looks like this. And so we're generally pretty cautious about commercial commoditization and think people should be, even though a lot of really cool stuff right now is happening in the machine learning space in commercial companies. And the last reason a machine learning technique becomes more possible than it was before is because data becomes available. And I put the data science page on Wikipedia up here for 2 reasons. One is because Wikipedia is itself a data set that has been used by pretty much any language model. And the other reason is that until recently, the Wikipedia page on data science cited the creation of the Wikipedia page on data science as a major step towards data science becoming a real thing. So thank you to whoever fixed that finally, but it was the most Wikipedia thing I had ever seen. But this is itself, one of the dirty secrets of data science is that so much is built on this data set. And when new data sets become available, it opens up whole new possibilities for people who have access to that. And that's why if you have a proprietary data set, that can be very powerful. And the other, sort of the corollary to that is data is actually made useful to you. So there's a lot of data out there that is not useful. This is from a ProPublica project where they took Medicare surgeon success data, and they made this visualization where you can actually see if you're having one of a set of procedures at different hospitals, the outcomes for your surgeon. And so this was data that did exist, but was completely inaccessible to consumers and was also fairly inaccessible to developers. They did a huge amount of work to interpret and visualize this in a way that's useful and then make it available for other people to build on top of. And so that Dark Sky app I mentioned earlier is another one where they've built a ton of APIs, and now there are other apps built on top of that. So they build on top of public data that they've made useful and easy to access through their API, and then you have other companies like Poncho, which is a weather company, building on top of their API. So it's a wonderful chain of things becoming possible. And now I'm going to talk specifically about some technologies that we're very excited about that meet these criteria, some more than others. One of them is natural language generation, which is taking structured data and generating English, generally English narrative. Again, part of that bias towards English comes from using Wikipedia as a data set all the time. which is a problem for us. Not us specifically, but us as a community. But natural language generation, so when we write about these things, we write little books. They get letterpressed by hipsters in Brooklyn on 100-year-old machines, which are super cool. And then we build systems or prototypes of everything we look into, because I don't believe you can really understand something without actually having built it before. And so when we decided to look into NLG, we decided to work on a data set that was not out in the market in any way and also could actually be useful to someone. And so we came to real estate data and built a real estate listings generator. And this was in a 3-month project, so it's something that's fairly accessible today, but newly accessible. And what you do here is configure your apartment in New York for this demo, and then it spits out potential advertising text, all auto-generated. And this is based on around 100,000 samples of real listings. There's an arbitrary scoring function that prioritizes more adjectives and more descriptive language to boost up those things. So you'll see the results that actually get displayed to you. Even though 1,350 were generated, the top 3 are all very over the top, but real estate agents do write like that, which is ridiculous. And we found a bunch of things in the data that were just curiously really interesting. So in New York State, if somebody says an apartment is cozy, it is 400 square feet smaller than the average. So you know that, but it gets better because if they say it is large or grand or big, it is at the average or slightly below. There's no statistical significance there. But that tells me we uncovered this unconscious bias of real estate agents, where if they're ever talking about size of a property, it's a small property. And so that was fun. But we did this more to show that if you have this kind of data, structured data, you can actually generate reasonable narrative with a fairly simple algorithmic approach today. And most of the time when you see this technology covered, you see articles like this. So, robot journalists, and journalists like to freak out about how algorithms are going to replace them. Though I would argue that if all they do is take structured data and turn it into narrative, that's a very good thing to be replaced because it must be intensely tedious. The products that are in the market today generally do sports reporting or financial news reporting, but they don't do anything creative. But what I think we'll see is the real impact of natural language generation is not in replacing reporters, but rather in taking complex data and making it really simple in a timely way. So imagine that you're in a bank. This is something we've seen in the real world where somebody comes in, they have a 20-page customer file, they sit down with a banker, and that banker gets 2 sentences that says, Hilary has been a customer for 10 years, she has a mortgage, you might want to sell her these things, or be aware of these things, right? So taking data and making it, you can make a graph, but even that requires a lot of work for people to interpret, and I think we'll see lots of data not rendered in graphs, but rendered in language. Which is something that's pretty interesting and offers a ton of opportunity, especially if you think about combining it with some of the chatbots and other exciting stuff that's going on. So another thing we're very excited about is using probabilistic methods on stream data, which is actually a very old set of techniques, but really underutilized, perhaps because of the commoditization piece, where traditionally it's much easier to do batch analysis than it is to do real-time analysis, but these are techniques that allow you to use a fixed amount of memory and a fixed amount of CPU to maintain online calculations in a pretty interesting way. If you were ever to build a device like a tricorder, you would need techniques like this, so that's one reason I find it pretty exciting. And to demo this, we sucked in all of the public Reddit comment data and visualize in real time the conversations that are happening. And so stream data that we've seen in the wild tends to be social media data or sensor data, which is really quite different, or it's transaction data. But social media is always a great demo because I can tell you I have a lot of experience with it. It is always really funny. So this is just a random screenshot from the other day where people using the Twitter hashtag #WhyI'mSingle are using the same language as the Reddit community's shower thoughts. It just seems to work out nicely that way. But this is an area where you can go, like there's an article with this headline written every month, and it's absolutely true. There's a lot of exciting stuff happening with streaming data. The last one I'll talk about is deep learning, which is hard to avoid these days, but it is actually incredibly exciting. We looked specifically at image analysis, looked at the history. Did you know that the original perceptron was actually hardware? So it was, the weights were potentiometers, and they were changed with actual motors. It totally blew my mind when I figured this out, and I built a little janky one that worked a little bit. But we're seeing this actually, show up in the Google Deep Dream example. I wanted to throw this in here as well because I have not seen anything so beautifully mathematical and awesome that was so frivolous come out in a long time. And it also is really creepy, and it's a great way to show people, like, this is what our systems are learning to recognize. It's Jennifer Lawrence, and then it's eyeballs. It's really a cool way to think about this stuff. When we demonstrated this, we built a little app called pictograph.us, which you can play with. It's public, so you can opt in with your Instagram. And it makes a visualization of what you like to take photos of from the contents of those photos. So it says, I take pictures of shores. I take pictures of weird things. So here's someone who's better. This is Tourism Ireland's public Instagram account where they take pictures of valleys. They take pictures of shops, fortifications, and rail fences. We have another prototype as well where you can sort of say, like, when people take pictures of cats, what else do they take pictures of? What are in those pictures? And where in the country do people take pictures of mountains versus oceans versus trees, and all that sort of fun stuff. And this is really, when we think about deep learning in particular, those 4 criteria I laid out for why something becomes interesting, deep learning hit all of them. And that has been really unusual to see, where you have actual theoretical breakthroughs, you have changes in the economics that make things much more approachable, you have real work going on in the open source community, and you have data that has become available that makes this possible. So all of those things at once make it really exciting. And I want to end just by saying that predicting the future is actually really hard. So these are 3 examples from 1900 from some French artists, and I love them because they go from, I ordered them by like actually happened to plausible, I guess. The middle one we'll call Wikipedia, though I don't really know what's going on with the one kid who's like turning the crank and he doesn't get to learn anything. And then on the right, it's not what happened. So of course it was France in 1900, so buildings burned down all the time, and they assumed that would still happen, except our firefighters would have wings. Maybe the wrong thing going on there. So it is really hard to predict the future, but that doesn't mean it is not worth trying and worth being excited about and being open to being both right and wrong. And I also think that as data scientists, we have an opportunity right now to think about what this next generation of products looks like. We're the ones who are going to be building them, and to really think about the world that we want those products that we want to live in, and how those products will help us live in that world. And so using data, again, not to exploit people, but rather to support them and to build some really great stuff. And so what's next? I think it is sort of what I said earlier. People and organizations combined with these new tech capabilities and the data assets they have will actually lead to good products. Some people do this really well, some people don't. I think it's something anyone can learn and can work in any sort of organization if they have the ability to laugh, basically. And I will end by saying, once again, I really do think data products give us superpowers in the sense that we are able to build things that increase our ability to understand and interact with our world. And we are really just at the beginning of seeing the impact of all of these data products. I think if we have this conversation in 5 years, we will be amazed by what has changed. And it's going to be really exciting. So someone's going to build it. It's going to be us. Let's do a good job. Thank you very much. And I believe we have
just a few minutes for Q&A. If you guys have questions, please raise your hands, and I have a couple of volunteers over here with mics.
There are no questions.
Looks like everyone got everything.
Had a
Thank you.
question in the back?
Oh,
Great.
right there. Perfect.
Thanks. Terrific talk. I'm wondering about your thoughts about the role of data science and data scientists in creating self-service tools. Yeah, so I'll leave it at that.
So I think inside of organizations, it is to the data scientist's advantage to push out as much of the data analytics capability into the organization as possible. That said, there are ways to do this that really empower people, and there are ways to do it that really become intimidating and sort of force people to hate data and not find it to be useful. But I've seen many successful cases where data scientists have led the creation of dashboards or tools that allow business users, we'll say, which is a nice phrase for people who don't write code, to actually ask questions and get reasonable answers, where those questions are things that build on work the data science team has done. So maybe they're curious about, like how many active engaged users did we have this week versus last week? That's the kind of question a business user should be able to ask without bothering a data scientist. But the question of what is an active engaged user is a question for the data scientist, right? So products and systems that can be built that allow the data scientist to do that foundational work and then to take that piece and sort of push it out are very useful. And I've seen this done really well, actually, in a lot of home-built sort of dashboards, and then more recently with a lot of products that are out there to fill this specific need. So that's my opinion.
Yeah, I have one question. Are you familiar with the Waze application?
Waves? Yes.
Yeah. So what are your thoughts about it? Because what I've seen, a lot of people use it here in the Bay Area. When it tells you to take a shortcut, everybody takes the same shortcut, and it doesn't work.
Yeah. So I should qualify my answer to this by saying I'm a New Yorker and I don't own a car. And so for me, driving is a novelty. And I go, woohoo, this is cool. So yeah, that's a problem in the product design, right? So they should be able to adapt where they might realize, okay, we're sending too many people because everybody here is technical enough to have Waze running this way. But I imagine that you in the Bay Area are on the edge of pushing the product, and so probably suffering the most consequences. But I would hope that eventually they'd figure out. It's actually a really interesting question, though, because at a given point in time, there's a certain shortcut that makes the most sense. But if everyone takes that shortcut, we know it's not going to work out well for everyone. So then are you happy being shown a less optimal path so other people can get access to the shortcut? Yeah, that's a good one. Yeah, I have no answer for you.
Thank you, everyone. Thank you, Hilary, for the awesome talk.
Yeah.